This is a video on discrete mathematics. This is different than calculus or differential equations. It's not as numerically intense. It's more like symbols, and it's funner for me. So the first lesson is on propositions, symbols, truth tables, and it's going to lead to logical equivalences. Okay. Here's a definition. A proposition is something that is true or false. It cannot be true and false at the same time. It's usually denoted by a lower case letter. Another name for a proposition is a statement. We're going to look at symbols. They're like operators. It's like addition, subtraction, kind of, in discrete math. The first one's not, and those are the two symbols for it. Then it's and, that's a symbol, or. There's also some other ones, but they're not the fundamental. It implies. You can make that out of and, or, and not. There's also exclusive or, which is like a cross with a circle on it. The negation of P is a squiggly line and a P. Conjunction of P and Q is P and Q. Disjunction of P and Q and P implies Q. We're going to look at truth tables. The first is not P. So we draw true or false. So the opposite of true is false, and the opposite of false is true. We're going to look at P and Q, and then P or Q. So since there's two variables, there's 2 raised to the power 2, that's 4 possibilities. So true and true is true, true and false is false, and false and true is false, false and false is false. Now we're going to look at P or Q. So if one of them is true, then it's true, and if both are false, then it's false. This is a definition for propositional forms. It's just when you add P, Q variables and the logical operators, which is not, or, and. This is a definition for logical equivalence. It's like the equal sign, but with an extra line at the top. And that's when a propositional form is equal to each other. That's another, the arrow sign, that's another one in LaTeX. And it means equivalence. It's kind of hard to draw, so people usually don't use it. And for the propositional form, it usually means a capital letter. Here's an example. P is logically equivalent to Q. We're going to prove that a double negative cancels out using truth tables.